Yes. Hey, hey, hey. Welcome back. Yeah. And let's continue our recursion series. And not recursion, I mean backtracking series. And now let's solve lead code 17 on the letter combinations of the phone number. And yeah, remember the prehistoric ages like long ago when you were a small child, we had button phones. And in button phones, what we had to do for example, if you wanted to type hello, then you had to press 4 twice to get H, and then 3 twice to get E, 5 tries to get L, 5 tries to get L, and 6 tries to get O. Yeah, remember those times once upon a time. And yeah, it's basically that question. So, but it's not like they're asking you to type out a number because I think if they ask you to like if they give you a text and tell like what numbers have to be typed how many times, that is like really easy to do. But this is a bit of a different problem. So what the question is that you will be given the numbers uh, like digits. You will be given the digits, and you have to tell all the combinations of letters that can be made using the digits. For example, using 23, you can type A, A, D, A, E, A, F, A, D, A, E, A, F, 2, 3, 2, 3, 2, 3, and 2 twice, D, 3 once, so B, E, B, D, B, E, B, F, and 2, like 2 thrice, 3 once, 2 twice, 3 twice, 2 twice, 3 thrice, and then 2 thrice, 3 once, 2 thrice, 3 2, 2 thrice, 3 3. So A, D, A, E, A, F, and yeah, C, D, C, E, C, F. So yeah, you have to give out all the combinations which can be done like that. And yeah, again, this is like pretty straightforward backtracking solution. So let's just return something. Let's just return an empty and yeah, to get the constants, it's given that digits names will always be less than 4. And the digits at position I will always be 2 to 9. Yeah, that is good because as you see, 1, 0, star and hash don't actually have any mappings to any letters. So yeah, let's do 2, 3, 4, 5. And let's just see how many combinations are like available. And as you see, it is a lot. So like first two, all one times, all one, and this twice, two, three, four, once, this thrice, thrice, two, three, four, two, three, four, one, four twice, five, one, two, three, four twice, five, one, two, three, four thrice, five, one. Yeah, it goes on like that. So that's the reason there are so many possible ways to like write for the given number. And yeah, again, it's pretty straightforward what we have to do. And yeah, the first thing we have to do is actually map every number to its corresponding alphabet. So let's do that now. Yeah, and let's call that mapping. So as you see, the letter 2 is mapped to ABC, 3 is mapped to, 4 is mapped to, 5 is mapped to JK, 6 is mapped to MENGO, 7 is mapped to PQRS, and then 8 is mapped to TUV, and then 9 is mapped to WX, Y, and Z. Yeah. So we have all the mappings, so we have to backtrack to fast. And so, like, yeah, just think about it. So you have to start from the zeroth number and then go and check all the possible numbers. So backtracking will obviously start from zero. Yeah, start it from zero, and then yeah, you need some container to hold your answer. So let's declare the answer variable over here. And again, the same way for every backtracking problem, you will have a temporary variable to store all the current possible combinations. So let's have that over here. Yeah, and there's no need to actually specify answer over here because the answer is actually present inside our letter combinations, and so is our backtracking part. That is the main reason there's no need to actually specify answer. Backtracking will automatically take answer as a global variable and update it. But here let's specify it to make it more cleaner. So you'll have the current ID, not ID. I don't know why I'm telling ID from yesterday. The current index, and then the answer and the temp variable. And yeah, when will your temp actually become like filled with your answer? That is only when the four digits have been pressed. And what does it mean that four digits have been pressed? That means that the length of temp has become four. So if the don't tell it that it has become four, when it has become equal to the length of the digits present, like for 2, 3, 4, 5. If it become like you will tell that yeah, since the length of digits is 4 and length of temp is 4, that means that all the numbers were pressed once or twice or thrice. It depends. Like two once, three twice, four twice, five thrice. Also is a possible valid is a possible valid combination when it becomes equal to the length of digits, right? Yeah, that means that you have actually arrived at your answer. So append the always append the copy because you will actually modify the temp and then return, or else what you have to do for you have to iterate through each character of the given mapping at the given position of ID. So what you have to do for each character of mapping at the position IDX, and this IDX is actually 0, but we don't actually want to check for 0. We have to actually check for 2. So it is actually digits at the position IDX. Yeah, now we are actually checking for 2. First append it to the temp, the character, and then do the backtracking. Yeah, backtrack from since the ID has already been checked, so increment the ID by 1 and then pass the answer in the temp. And after doing everything, pop out from the temp. Yeah, by now what will happen is that our answer should be populated. So let's just print answer to check out. Okay, I'm calling it backtrack in one place. I'm calling it backtrack in one place. Let's just correct that. Yeah, it looks like our answer is done. But the thing is, it's actually in the form of an array. So what we have to do is that, yeah, let's directly join it over here. Yeah, directly let's return it also. Oh, and yeah, okay. What is this? Yeah, where's our code? Oh, what is this UI man? Ah, well, let me just restart the page itself. And yeah, it's happening like that. Okay, I can do this, or I can't. Yes, that's what you want to see. Let's pull the test case to specific position. Yeah, the only test case which is failing is when there's no digit, then you have to actually return an empty array, not an empty array with some string inside. So return answer if the digits exist. Else, just return an empty array. Yeah, now it's working. Let's just submit it to check if the implementation is correct. And yeah, it works and it's pretty efficient. I think there might be some other ways also, but backtracking is the best way to do it. And yeah, I hope you understood what to do. Take every mapping part and first map every number to its corresponding digits, and then define the backtracking. Start the backtracking from zeroth index. So you have to when you are given 23, you have to start from two itself. So take two and first check if the length of temporary is equal to the length of digits. If it has become equal, that means that all the digits have been pressed once. So you can directly return the like append it to the answer in return. or else for every character in mapping at the position and digit at the position index. So for example, you are checking for 2, so go to mapping. So for in the mapping, you want the actual value of 2, and the actual value of 2 is that digits at the position index. Yeah. So when you do that, you'll actually get ABC. So what you'll do, you'll append the value of first character, like for each character you're going. So first in ABC, you'll first go to A, append it to our answer, backtrack for all the characters in ID plus one. So since we have been already checked, go for 3 now. That's what it's telling. And now it will go for 3, and the length of temp is actually 1 over here. And again for 3, it will again check for D, E, F, and it will check for D. So it will add D to our array. That's why it will become A D. And yeah, by now what will happen is that the digits will actually become equal to the length of digits will actually be equal to length of temp. That's why you'll put the current combination and then return. After returning, what will happen is that since 3 is checked, now it will go for the since D checked, D is checked, we will pop out the D also, and then we will go for E, and yeah, E will be the same thing will happen again and again. Yeah, that's how the backtracking works, and yeah, that's all for it. Thank you.